Hello, friends. Welcome back. Here we are again, live on YouTube, ComfyUI. I wanted to do some somewhat simple, sort of intermediate AnimateDiff stuff here, where we make an animation with Blender and then dream over it. So we're going to use the animation that we made in Blender as a source, and then we're going to dream over top of it. So here I have a tunnel video that I made in Blender, and I'm using this as a fake depth map. And the end result is this crazy animation with the eyeball here. So you can kind of see the movement there if I sync these up. Yeah, see how it's sort of following the movement of the depth map? Now, you don't necessarily have to make this video in Blender. If you have videos you want to use, I can go over that too. But for now, I'm just going to go start in Blender, make this, and then we're going to come back and put this in ComfyUI. I'm going to rebuild this workflow. This is a pretty simple AnimateDiff workflow. It's pretty normal. Nothing too crazy or out of the ordinary. So yeah, let's get kicking. I'll load up Blender and start a new project. So if you don't have Blender, go download it, install it, and then open it, and you'll see this. Let me turn on my screen keys here. Oh, they're on. Let me enable them. There we go. Okay. So we're back. Here we are in Blender. I'm just going to make a very quick tunnel in Blender. We're going to kind of speed run this. So if you have questions, feel free to drop them on the Discord or in the chat, and I'll try to get to them as we go along. But yeah. All right. So first things first, you click that default cube and hit the delete button and obliterate it from orbit. Shift A. You want to add a circle curve. So you add a curve and it's a circle. Curve, circle. All right, so it's going to give us a circle. We're going to go over to the circle and we're going to increase the resolution to 64 on both of these. That's in the Bezier circle data settings. So click on Bezier circle, click on this little green hula hoop thing, like nodes. Click that and then change your resolution up. We're going to do a lot more stuff from in here as well, but first I'm going to make this curve a little more interesting. So I'm going to click on the curve and hit tab, and that's going to open edit mode, which is going to give us, points that we can look at. These are the 4 points that make up our circle. So let's hit A, and that's going to select all of them, and then we're going to right click and we're going to hit subdivide. That's going to make it 8 points now instead of 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to hit the little Z arrow to bring the camera perfectly 100% looking down like this, so that I can grab them and start moving them. So I'm going to make a racetrack out of these by just grabbing them, hitting G, and then just moving them around. Grab it, hit G, move it, click. 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 All right, we got our sweet little racetrack here. Now our racetrack is perfectly flat, which we can also change. The other thing you want to do is try to make it so that your points are around the same distance apart from each other, or what'll happen is the track will speed up in those sections. It's not the end of the world, and it's a way you can control the sort of speed of your motion. But if you want it to be somewhat consistent, try to keep these points an equal distance away from each other. All right, so we got these, but the track doesn't go up or down. It just goes flat. So let's grab one of these points, hit G and then Z, and we're going to lock it to the Z axis. And now we can move it up and down. Okay, so let's move it down. Let's grab this one, GZ, up. Move this one, GZ. Actually, let's grab both of these. You can box select by selecting above and beside one. I got 2 selected, GZ. I'm going to bring that down. This one up. This one up. And there, we have a track. It's 3D. It does cool stuff. So before I add the track itself, I'll add the camera. So we got our camera in the scene, but our camera's way over there. So we need to make sure you hit tab to go out of edit mode. This is a common mistake. I still make it to this day. Any changes you make on edit mode, even if you click on other things, will only happen inside the thing you're editing. So yeah, click it. Got our crazy, you know what? I actually don't like the position of that. I'm going to move it over. GY. Yeah, that's better. Okay. Yeah, you just want your track to have a nice smooth movement to it. So let's take our camera on back in edit mode. So hit tab to get out of edit mode. Make sure you're in object mode. It says up at the top here what mode you're in. All right, I'm back in edit mode or object mode. I click on camera. I want to actually click on this, drag down and to select all of them and then let go and hit 0. So I want to actually put the camera dead center, pointing straight down, because I'm going to actually attach it to this track and then move it along over the course of the animation. So let's make this animation 90 frames for brevity's sake. So that's down here in the timeline. Our start is 1, our end is 90. So we have a 90 frame animation. So we're going to take our camera and we're going to use this pinball thing, the constraints thing, and we're going to add an object constraint. And that constraint is follow path, because we want this camera to follow the path we've created. The target is the Bezier circle we created. So now the camera is actually going to be on the path. You can see that. And if I move this offset, it's going to move along the track, which is great. But right now the camera is pointing straight down, which is not good. So to orientate the camera correctly, you have to go -Z, Y. Just remember that, -Z, Y. Forward axis, -Z, up axis, Y. And click follow curve, okay? So these are the settings here. And now the camera is moving along the curve as we go down in numbers. And if you'll notice, 0 and -100 are the exact same position. So every 100 frames, this thing does a loop. So in order to get a perfect loop, we need to go to frame 1, shift left arrow to go to frame 1, hit I on the offset value, go to the final frame, shift right arrow, right once to go to frame 91, and set the offset to -100, and then hit I on top of that again. Okay? So now if we hit spacebar, our camera's going to race around the track. This isn't going to look as exciting here in the mode because, you know, we don't have anything in our scene. So it's just kind of whipping around like crazy. And this is also another problem we have because our animation is so short. The camera movement's actually kind of insane. So I might have to actually adjust this a bit once we get kicking, but let's start playing and see what happens. So the thing we need to do here is to add some geometry to our circle to get something the camera can move around inside, because we're making a tunnel. So we want to go to the bevel in the Bezier circle data settings, and we want to increase the depth, and that's going to make a little tube. So we want to make the tube big enough that the camera fits inside, but not too big that the tube intersects with the other sides of the track, right? So now if we look at our camera, we can see our thing is flying through a tube. Let's actually go to our camera settings and decrease our focal length quite a bit to try to get more thing. Yeah, see, this animation is great, but it's way too fast. And that's because I only chose 90 frames. So what I'm going to do is actually increase the length of this animation, and then we just won't do as many frames to make a perfect loop. But when we come back to Comfy, you would have to do the entire animation to get a perfect loop. So we'll just do a shorter chunk of it, so you just for time's sake, so you can see what we're doing. But if you wanted to do the whole thing, you would have to render out the whole thing. So I'm just going to make this longer so that the animation is not insane, and then we'll come back to it. So I wanted it to be 90 frames, but I'm actually going to go back to the Bezier circle here into the, or the camera settings rather, for the tracking settings. I'm going to remove, right click, remove this keyframe, or clear all keyframes actually. So right click, clear keyframes. So our offset should be back to nothing, because now we want to increase our range of the run to 240 frames. So that'll make it a 10-second video. So let's click I on offset at 0 on the first frame. Go to the final frame, 241. Shift right, -100. I to insert keyframe. And now, because the animation is longer, it's just taking longer for the camera to get through the tunnel, which is giving us a much smoother animation because it's not going so fast. So now that we're inside, we can actually use the settings in the Bezier circle, bevel settings, to figure out exactly how big we want that tunnel around our camera. So if it's too big, you won't really get to see what's happening because the tunnel's intersecting with itself. If it's too small, you kind of want to just find the happy medium there where it fits inside the camera and you get some nice, cool movement. This looks pretty good. So another thing you can do is grab this camera here and go down to the camera settings into viewport display and crank up the passepartout, and it will get rid of all the stuff that's not in the view of the camera so you can see exactly what we'd be seeing in the mask. And now that our tube is doing the tube thing, switch to Eevee, and we're going to change our resolution. That's in the scene settings here. We're going to change our resolution to 1024 by 1024. Okay. So now we notice the bounds of our mask is actually outside the animation, so that's not good. What we need to fix that is to take the camera and just move the focal length. See, the focal length of the camera determines how close the camera is sort of to the action. So you want to back it off so that you get a nice view, but you also don't want the mask clipping outside the bounds of the camera all the time. So that looks pretty good right there. And then we can turn this off. It'll get rid of those extra grid lines inside. All right, this is a pretty cool one. So in order to pretend that this is a depth map, because the easiest way to do this is to make a depth map, what we can do is have a look at our display here, all big, and you can see the camera going around the track. What we want to do is put a light exactly where the camera is and have it travel along with the camera to light up what the camera can see to make a depth map out of the inside of this tunnel. So first things first, I'm going to grab this and I'm going to duplicate this curve because I need the curve to move the camera around, but I need this curve to be a mesh in order to do anything cool with it. So I'm going to hit Shift D and then just click. And what that'll do is make a duplicate of this. Shift D for duplicate. And we're going to call this one the racetrack. And we're going to call this one the racetrack curve. So the racetrack curve we're going to leave alone, but the racetrack, we're going to click on it. We're going to go to Object and we're going to convert it to a mesh. So now we have two. We have the curve and the racetrack. The curve also has a mesh, but we don't need it anymore. So we can hide it from view. Okay. So now that's these little buttons here. This is our viewport and our render. You want to remove it from both of them. And now the curve mesh won't show up, but the mesh we made will. Our camera will still run along the racetrack curve. It just won't be showing the mesh that's attached to it. So now that we have this mesh, this is a mesh, not a curve. If I hit tab on it, it's got actual geometry, right? So now we can do cool stuff with it. But more specifically, now we have a cool tunnel that is all correct and everything's ready to go. So we need to add our light. So let's kill this light. And we're just going to add a new light point. So it's going to put a point light dead center in the camera or in the screen, but we want it to live with the camera. There's a few ways to do this, but the easiest way to do this, I think, is to just grab that point and attach it to the exact same path the camera is attached to. So take the light, point light, follow path, curve, -Z, Y, follow curve, and then just have it run around the track with the camera. How do we do that? Frame 1, it's at 0, I. Frame 241, -100, I. So now the light will be following the camera and lighting up the path in front of the camera. Now we can use the power of the light to determine how, insane the depth map is. The other thing we're going to do is change the background of the scene to pitch black. And what that's going to do is let us determine exactly how much white and how much black we want in our depth map. You just want a decent contrast. 1 watt is probably perfect. 2 watts probably, actually maybe better. And the other thing we need to do is go up to our render settings up here and go to color management and change that to standard because we want white, not gray. And yeah, play with the light. Try to get it exactly the way you like it, because you want it to be dark where it's farther away and white where it's close. So let's go with 1.5 maybe 2, 1.5. Yeah. And let's take our mesh. Now that we have our mesh, you notice how it's got these sort of wonky edges here, these little cuts in it. That's because there's not enough geometry in our things. So this is what we're sort of flying through here. So we need to increase the geometry without increasing the geometry. But to do that, we need to subdivide the surface of the curve so that the curve is smooth. So let's go back to our rendered view here and just add a modifier to the racetrack called subdivision surface. And we'll go to level 3 for both of them. And that should be nice and smooth. And it is. Cool. So our animation works, it loops, everything's cool. We're going to render it now. Oh, another cool trick is in your camera view, if you don't like the way that it's going, just grab your camera and you can rotate it on the Z axis. 90 degrees, you know, that'll make it go down because it's turned the camera around. 270 and make it go up because it's the other way around. So 0, it's all going to the right and the left. You know, you can just play with this and try to get the exact animation you like. I'm gonna go 90 because I actually kind of like that sort of up and down motion and the fact that the tube keeps sort of going down. And yeah, and then we are going to go up here and pick a folder that's in the scene settings, the output settings here. Change our output folder to whatever you like. I'm going to put this depth tunnel 4 because I think I've been making a bunch of these. Depth tunnel. That's fine. We'll change this to FFmpeg and color management. No. Encoding. We want to change it to MP4 and perceptually lossless. So these are the settings right here. FFmpeg video, MPEG 4, perceptually lossless output quality. And the URL, the file path to the video you want to make. Okay. And we're just going to do this in Eevee. I think it'll be fine. You could do it in cycles if you want. It'll just take longer. It'll look better, but it'll take longer. So let's do a render and see how it looks. So you go up here to render and hit render animation. And Blender's going to crunch all the frames now as we sit here. Yeah, I want to help try to demystify Blender a bit. It's not as nearly as scary as it seems. It's just there's a option paralysis that comes with being able to do basically anything with software, so I get it. But if you just pick a simple task, one task, you know, you can get there. Hey Splinter, we are making a depth map animation in Blender that we're going to then turn into an animation with ComfyUI. So right now we're making the input footage. We just built a tunnel in Blender, and right now it's rendering out all the frames to make the video. It's about a 240 frame video. And when it's done, we're going to pull it over to ComfyUI and build a workflow around it. Hopefully everyone's doing good tonight. Kind of just dove right into it with no hellos, but you know, that's what you're here for. Render, 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 render. All right, let's have a look at the video we just made and see if it's a suitable depth map or if we need to do it in cycles. I think this is going to be fine. Yeah, let's hit it. So let's take our depth tunnel here. Actually, let's just delete all this and start over. Get the hell out of here. All right. Here we are back in ComfyUI. Let's start from the very beginning. Let's load checkpoint. What checkpoint do we load? Let's do an LCM checkpoint. Today we'll use Realism by Stable Yogi, LCM. You can use whatever you like. If you don't use an LCM LoRa, or LCM model, you will need to use an LCM LoRa because we're doing AnimateLCM today. To do that, you just add a LoRa loader. You add the LCM LoRa, which is this one, LCM SD15. And then you run the clip through it. Today I'm going to turn it off because we're not actually using it, but I'll wire it through just so you can see how it works. I'm using an LCM checkpoint, so I don't need this, but this converts any regular checkpoint into an LCM checkpoint. We do this to make things go faster. So out of the model, actually out of the clip, we're going to add a clip text encode. So just drag the noodle out, hit clip, let go, clip text encode. Control C, Control V, make yourself a second one. And that clip goes through. So it goes through the LoRa loader and into the clip encoders. And these are our text prompts. So this is our positive prompt, and this one is our negative prompt. I'm just going to slide these under here. I'm going to set a global resolution to begin with because it just makes life easier. So we're going to do a primitive node, a primitive integer node. These are available in Chris tools, but there are primitives. There are even primitives built into Comfy. So just search for primitive, and we want integers because they're not decimals. Integers are numbers that don't have decimals. Floats are numbers with decimals. So we're going to set our resolution to 576 by 320. That's our base resolution for AnimateLCM. So I'm going to call this one width. I'm going to call this one height so that we're just setting it in one place. Anytime I need width and height for the project, I just plug these in. Makes life a lot easier. Okay. Model comes out into, I'm going to use IPAdapter first. So IPAdapter unified loader. And this is going to save me from having to prompt, basically. So we're going to set that to VitG, I think is probably good. We're going to add a IPAdapter Advanced. I can spell IPAdapter Advanced. Plug the IPAdapter in. So yeah, this is how the model chain works. It goes into IPAdapter loader. So it goes out of the loader into the first IPAdapter node. If I were to run another IPAdapter node for reasons, the model would go through them like this. But for now, we're just using the one. So don't sweat it. All right. We're going to image scale to total pixels. Image scale to total pixels at about 0.4546. That's going to give us like about a 640 by 480 image. It'll resize whatever we stick in here to the right size for IPAdapters, essentially. And then we're going to go to load image. And actually, that one might be fine. So this is what we're using to define the look of our animation, this IPAdapter stack here. Just add some groups here so we don't go insane. All right, so let's call this one settings. Yep. All right, and then this one will be IPAdapters. All right, what's next? AnimateDiff. We're just going to use the legacy loader, AnimateDiff loader legacy. We need context options, looped uniform context options. Yes, I am aware of get and set nodes, but I do not use them. All right, 16.1.4 and sample settings. We're going to add that as well, and we're going to change that to empty. We don't need a lot of noise because we're actually using input footage for this. I might go into that a little deeper in a minute. And we're not going to use a motion LoRa because we are just rocking the regular we're just rocking regular AnimateDiff settings and we're doing cool stuff. So don't sweat the motion LoRa for now. We got our loader, we got our context options, we got our sample settings. That's all we need for AnimateDiff. Now the model is going to go into a K sampler. Our positive and negative are going to go into the K sampler. And the latent image we're going to get from an empty latent image node. So drag that out, click empty latent image, right click on the widget and change the width and height to inputs. Okay. Then we're going to grab our width and height from here. Skabam. Okay. Our batch size is actually going to be determined by the mask we use for ControlNet. So we're not there yet, but let's move this down. And we're going to need a VAE decoder. So let's add that VAE decode, plug the VAE in. Actually, I'm going to use a different VAE. I'm going to use the VAE FT MSE 840000 EMA pruned. You can Google this VAE FT MSE 840K. This is a common VAE used in Stable Diffusion 1.5 to make things look better on the way out. One thing is I'm going to set the motion scale to 1.15 in the AnimateDiff loader and change the mode to animate greater than, or LCM greater than square root linear, and change it to the AnimateLCM T2V model, not I2V. I2V is for a different node. Text to video, image to video. We need an image node to make it happen. It's a whole thing. Decoder goes into a VHS video combine. 24 frames per second, MP4. Okay. 24 frames per second. AnimateDiff. We're going to make a folder called ADiff depth test. And the thing will be 24 frames per second, low res. So this is basically a naming structure, you know, for what to do. It's going to make a folder and then put the animations in here with information about the animation, which is a hell of a lot more useful than just having a bunch of files called AnimateDiff. The CRF we're going to set to about 13. The lower this value, the higher the quality, the less compression that goes on your video. But there are diminishing returns around 12 or 11. It's just way more size with not a lot of quality gain. So like 13, 12, 11 is probably like your max quality value sort of thing. We're going to save the output. Yeah, everything's fine. So I moved this stuff out a little bit because we actually have one more component to add here. And this is sort of the secret sauce to making it do the thing. And that's we need to add apply ControlNet Advanced. Okay. And we just plug the positive into that from the clip. And then it goes out from there into the K sampler. So it's going to be in between. Pull ControlNet out. You want to load the ControlNet loader Advanced. And we're going to use depth. The image is going to, first things first, we're going to image scale, all one word, which is upscale image. Crop its center. And you guessed it, convert the width and height to inputs. Grab them from here. Now, whenever we change the width and height, we only got to do it one place. It's nice. All right, let's load a video. So video load or load video. Yeah, load video upload. Let's upload the video. Depth tunnel 4. Plug it into the upscale image. Plug the upscale image into the apply ControlNet. And now it's going to convert this input footage to the right size. So the one thing I need to change now is the batch size needs to become an input. And we plug the frame count from our input video into the batch size. So now our input video is determining how long our animation is, okay? Which will give us a perfect loop at the end if we do all 240 frames, which we're not. We're just going to do the first 24 to start. So let's add some groups here, color them, and then we'll run it and see if it works. We'll save that for after. So this is ControlNet, title ControlNet. And this is our K sampler, our diffusion. And this is our output, but we only have the one node, so we don't really need a thing for it. IPAdapters, I'm going to make it cyan. AnimateDiff, you are light blue, which I think you already are. ControlNet is yellow because it's on the clip. And diffusion is purple because diffusion is purple. Settings, I usually make green. This way at a glance, I can see what each of these sections is doing. And one more thing you can do is select all the nodes and convert their colors to those colors as well. And it tends to help your brain associate the nodes with the things that they do. And will sort of keep you sane over the course of time. I always make the VAE nodes red just so I know they're VAEs. And then these are always the image inputs and loaders and outputs and stuff. I usually make them blue so I can see at a glance where the images go. And these guys will be green as well. And let's move it all down a little bit. And just clean this up. All right. NSFW nude in the negative. For the prompt, I'm just going to add 4K, and I'm just going to let the image do the work here with IPAdapters. So let's check our wiring. We got our load VAE, our width, and our height. A load checkpoint goes into our load lower, which we're not using because we're using an LCM checkpoint. Feeds into our clip. Our clip does the text conditioning. Model feeds into IPAdapters. We're loading the VIT-G IPAdapter. 100% strength. We're resizing this image to fit inside IPAdapter's eyeballs. We're running that through AnimateDiff, and that AnimateDiff settings are set to loop when it's done. It won't perfectly loop because we're using a depth map that doesn't loop. Regardless, just keep it this way so that when you do a full loop, it'll loop. ControlNet is applied. The depth ControlNet is applied via this animation, and then it is diffused through this K-sampler. We have to set these settings too. I forgot to do that. LCM settings are 11 steps, CFG of 1 to 2, sampler is LCM, the scheduler is SGM uniform. Okay, those are the settings for the K-sampler. Wow, all right, cool. So that's going. I just thought of, oh yes, right-click on the K-sampler, convert the seed to an input, and just use a seed node in here, seed. And then just set that to fixed. And we'll just use a random value in the seed value. And this is going to fix the seed. This isn't immediately important, but it will become important if we add an upscaler. Okay. So I think this is ready to rock. That wasn't so bad, right? So what I'm going to do is just do the first 24 frames of the animation so that we can see if it's working before I do a whole 240 frame run. 576 by 320. Oh, let's try it. If this works first try, I will be amazed. So now this is using this input animation as the depth map for this AnimateDiff run. Wow. Wow, we got all the way there in 30 minutes. That's crazy. So yeah. And obviously you can start adjusting these settings. So if I back the strength of the ControlNet off a bit, the 50%. Okay, let me talk about these for a sec. So the strength of the overall ControlNet is how much ControlNet is applied to the animation. The start and end percent happen. That means like in the process of the render. Like right now we're 50% of the way through. The start percent is 0, so the ControlNet starts on, and it goes to 50%, and then it stops paying attention. So it's going to imply the movement at first, but you're going to get a whole lot more of the concept of the IPAdapter underneath when you back off the settings for the depth, so, or for the ControlNet itself. So it's all about finding the happy medium of these settings to get the exact motion that you want out of your animation. Ibrahim has a question. Every checkpoint has its own K-sampler settings. Sort of. Every checkpoint type. LCM specifically has a very specific LCM sampler because it's a distilled model, so it's doesn't work the way the other models do. But other checkpoints, when you're not using LCM, those settings are pretty much any setting will work with any checkpoint. They do different things. They all just essentially converge at different levels and different strengths. So like the ancestral ones tend to converge a little earlier, but they don't actually maintain the same image throughout the course of the diffusion. So, you know, yeah, read up on K-sampler settings if you want to learn about what all the different sampler names do, because they're all different specific ways of denoising the latent image into something humans can understand. RG3 fast group toggles. Yeah, they're all right. I just don't need them for this. Yeah, so as you can tell, changing the settings changes it quite a bit. You want to try and get a fluid loop, you know, you want to add more of the IP adapter, you want to add more of the input footage, back and forth, back and forth. But the other thing I want to talk about here is like how to get higher quality out of this, because like this is cool, but it's, you know, it's still very low quality. To do that, we're actually going to take the latent and we're going to add an NN upscale. NN Latent Upscale. It's in the manager. Go to custom nodes. NN Latent. ComfyUI neural network latent upscale. Add that, restart. You'll get this node here. The latent from the K sampler goes into it, and then you set it to SD 1.5, and then multiply it by 1.5. All right, and then that's going to kind of replace your empty latent image. You're going to grab these two, Control C, Control V, and we're just going to grab all the same stuff that's connected to it. So grab this. The model comes from AnimateDiff. Latent image comes from this. And the seed comes from the seed node. It's all coming out of the integer on the seed. Now, this is why I added the seed, because now I have this K sampler that acts as an upscaler. I'm going to copy and paste this, plug this in, and it changes to up instead of LR, so I know that these are upscales. So now I actually have a reason to make these into groups here. Where are you? Add group for selected nodes. All right. I guess we'll make you purple too. Why not? So this will be upscale. So we got our first run diffusion and our upscale diffusion. One cool thing you can do is add diffusion first run. And you can add diffusion upscale run or second run. Fusion, second run. Purple. All right. Okay, so for the upscale, we don't have to do as many frames or as steps. We can actually do 8. And that'll be fine. I make this a little bigger because it's a little bigger. Okay. So now this is going to do the same thing it did here, but again at a higher rate using this as the input footage. And because it's the same seed, you can actually bypass this until you need it, do a run until you like it, and then unbypass it and run it one more time. And because the seed is fixed, it'll just go through and do the upscale on the stuff that's still in the latent space. So if I do that now, it's going to break because I forgot to plug the VAE in. But yeah, because it was the same run on the same seed, all the stuff's in the latent memory already. It's just going to do the upscale now because I fixed the seed on both of these to the same seed. Now this is going to look bad because I forgot to change the denoise level. There's actually 2 things I forgot to do. So let's knock that denoise to about 0.56. This is how much of the original image comes through. The denoise level 1, it just fully dreams. 0, it just basically spits the input footage through. So on a scale of 0 to 1, that's how much strength it's giving the input footage versus the new dream. So again, this was set to 1, so this should be pretty wild. Yeah, I mean, it's cool, but it's not necessarily an upscale of this. It's just a new dream. So we want to actually make it an upscale. The other thing I want to do is before the second run, I actually want to add another ControlNet, and that ControlNet is called AnimateDiff ControlNet or ControlGIF ControlNet. So I'm going to grab these 2 nodes, copy them, paste them. So I've got another ControlNet set up. We're going to grab that positive and negative, and we're going to pop it through this. We're going to change this to the AnimateDiff ControlNet. Or it's ControlGIF ControlNet, I think. ControlGIF. No. AnimateDiff control. Oh, there it is. There's an XL version. What's that about? Anyway, it's this one here. I'm going to drop the link in the chat. So this one I'm using as a upscaler, because what it does is it tries to maintain the composition of whatever you slam in here. So I'm actually going to plug the VAE decoder from the first run into this ControlNet, and this ControlNet here is going to affect the final upscale. Another thing you can do is, if this is getting too crazy, you can actually just take the clip from here and pass it into here so that you're bypassing that ControlNet on the second run. So you're not over ControlNetting this input footage. So let's try that. So this is coming straight from the prompt into the, actually these settings will be all right. I noticed with this, about 0.6, 0.3 on the strength and N% seem to be the money. But yeah, this should try to take what it sees here and upscale it more than it did last time, where it was just dreaming a new dream on the same, same thing. Matisse, what's up, Matisse? Go follow my friend Matisse on Twitch. Or else. Upscaler ControlNet. Yeah, see? So now if we play with the denoise level, we can get more of the input footage coming through. If we play with, play with this, you can get more of the input footage coming through. You find that happy medium where you're not smoothing it out too much, but you're getting new detail in your dream. And then you can just keep repeating this process until you run out of VRAM. For example, right now, this process is taking 14.8 gigs of VRAM. So this might be as far as you can go with a 12 gig card, but if you have a 16, 24 gig card, you can keep pushing. Also, you do not have to upscale this way past this point. Once you get a good second run, like this one's pretty good. If this was a full run, I'd probably be happy with it. There's a node called the SD Ultimate Upscaler, and what it'll do is it'll upscale each section in tiles. So it doesn't actually take more VRAM, it just takes more time. But you can go really high quality with that. So yeah, don't freak out if you can't upscale in latent space. You can always use the SD Ultimate Upscaler to bypass that problem. So yeah, let's do a full 240 frame run and see what it looks like, because I'm curious. And I'm going to bypass the upscaler because we don't need to upscale the long run. Right. So now it's going to grab the whole video, jam it in the buffer, and do a 240 frame run. We just did a 24 frame run, so it should take 10 times longer as the last one. However, it should loop, which will be cool. How are you finding SD3? SD3 is probably the best base model that they've ever put out. That being said, it's heavily neutered and has some serious issues with anatomy and hands and people and things like that. So they overcorrected on the safety stuff, which is, I think, totally normal as a company. I don't know. It's a very strange place and a very strange time right now. So it'll be up to the community, I think, to fix what they can't provide. I'm not counting SD3 out yet, basically. The licensing, however, needs to be looked at. It just needs to be clarified. I don't know if it's necessarily bad licensing. It just needs to be clarified what that means for end users, training, and all that stuff. So that'll be cleared up in the next few days, I would imagine. But who knows? I'm having fun with SD3, though. It does really good text. Splinter says, what GPU do you have? Oh, this is a 3090. Yeah. Yeah, so like right now, actually, SD3 is actually kind of stagnated because of the licensing. Like even Civitai has banned it, banned SD3 models as of the start of this video. Anyway, that might be fake news tomorrow, but who knows? We'll see. We'll see. I think they will clarify the license for personal use. And I don't know if that means just telling people, no, this is the way it's going to be. And, whatever. Or does that mean, are we going to get a more concise license for trainers and humans to use? Because I really do believe that the wording and stuff in their license is more directed towards companies trying to spin up platforms using SD3. I don't think it actually fully relates to us, like as explorers and single-use individuals. But again, the wording is very vague, so we can't tell right now, basically. So yeah, that's why it's sort of banned from Civit right now, which is crazy. Haven't seen that one yet. That being said, there's all kinds of new diffusion transformers models dropping. The what is it, like 3 of them came out in the last couple of days, and they're all pretty cool. I mean, none of them have IPAdapters and ControlNet and all ADIF and all the fun stuff yet, but I think we got some ControlNets for SD3 already. I was playing with the Canny one and something else. Kajai's working hard on it. Dave says 24 gigs isn't enough in this game. Constantly fry my 4090. Yeah, it's more about understanding what takes VRAM and when to spend it. Basically, rendering at a higher resolution is not necessarily a better thing. Rendering good quality at a lower resolution is much better because you can always upscale it with something like Topaz or Flow Frames or whatever. ESR GAN, all that kind of stuff. You don't necessarily need to do all the rendering in the box. But yeah, look at that. Pretty cool. So I'm not going to make you sit through an entire upscale because, But yeah, you can imagine what that would look like upscaled. Pretty cool. And the reason it's sort of jerking around like that is because my my settings here are not sort of full, so yeah, you want to play with these settings on a lower run and then run the full shebang. But yeah, as you know, this is it. It's doing the thing. It's pretty cool to see them side by side like that. Holy crap, we got it done in an hour. I really thought this was going to take longer. All right, let's break it. So how do we expand this? How do we do more cool stuff? Well, let's move this stuff over a bit. All right, so let's add another ControlNet. What? Positive and negative go through each ControlNet. Yeah. And let's try, let's do a line art. And then I'm going to go into Blender. I'm going to take my little thing here. I'm going to turn it into a wireframe and see what that does. So let's add a wireframe modifier. I think this is actually going to be bad. I might have to do something here, but let's find out. Wireframe. Ooh, should not have put that after the subdivide. Ugh. Let's get rid of the subdivide for now. Sup, dudes? Tim, Hugh White memes. What's up, y'all? Okay, this is awful. Is it because of my thickness? Maybe. Let's turn that thickness down. Down with the thickness. You know what I'm saying? Actually, That might not be too bad. So right now I've added a wireframe, which is going to show me all of the stuff around the tunnel. Yes, I would reduce the geometry. The problem is the other one doesn't have reduced geometry, so I would have to render them both. I don't need more detail for this because they're just making depth maps. Okay, so yeah, so we're not going to replace the original. We're actually just going to add the wireframe on top of the original. And I'm going to go here. We're going to change the material offset for the wireframe to 1. So now I'm going to add 2 materials to my thing. The first one's going to be actually a diffuse material because I want to make a black surface that blots out all of the potential, things around it. And now this sort of wireframe is inside it. The wireframe is being lit up by the light. We don't actually need the light anymore because I'm going to make the wireframe a new emission shader. And now they will just remain 100% white all the way through. All right. So now if I take this and I render this out, it's going to give me a line art. I'm going to render that. And we're going to render this out. And this is going to be a very strong mask that will be probably turn everything into corn on the cob, but you can just basically see exactly what it does. So what you would do normally, if you were to do this workflow, is, to me, this is too much geometry. There's too many lines. It's going to get confused. So what I would do is, in the original thing, I would actually back this resolution off a bit, then delete the mesh, reconvert it to a mesh, do all this stuff all over again, and then you'll have your depth map and your line art. They have to be the same sort of tunnel. They can't have 2 different tunnels because it'll just create a clash when we use them as 2 different control nets. So I'm sort of locked into this resolution right now because of the depth map. They're having to render out the depth map again. We're gonna render this. All right, so now we have our line art animation. So we're going to pull that in down here. I'm going to copy these 2. We're going to grab the width and height from our, you guessed it, thingamajig. And here's a cool trick for chaining these together. I'm going to actually convert the frame load cap into an input, and I'm going to use the frame cap from the first one into here. So it's going to know how many frames to load from this one. So we load 24 frames on this one, and then I pick this one, and it's going to load 24 frames from this one as well, because the frame load cap is the frame out of the first one. So you can do that if you have different masks to make them all the same length easily. This is passed through. This is passed through. So I'm going to put this at 100%, and I'm going to actually bypass the first control net. So we're just seeing what the line art does. And it's set to 24. I'm going to unbypass this because it's actually creating the load count for this one. I don't know if that'll matter, but it's worth a shot. So let's move this over. Yeah. So now this should be superimposed over our animation. Find out. Oh, what did I miss? Ah, that's right. You need to plug the upscale image into the control net. Derp. Okay, so now it should do the line art control net. Oh, I think I had that set to depth. I do. Oh no, I changed it. Yeah, so you can see now it's taking the white marks and making line art and superimposing it into the animation. Cool. Actually, that's kind of neat. So yeah, if you did the whole run, you'd get a whole thing like that. But if we unbypass this stuff, I'm just hitting Control B, by the way, to bypass and unbypass. And Control will let you box select. Control click and drag will let you box select. You're good, 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 you're good. Okay, so let's back this off to 0.5, 0.5. So we're going to do depth and line art and see what that does. So you can just keep adding more control nets and exerting different types of control, different types of models and all that stuff. Ooh, lights on. I didn't do it, I swear. Wow. Yeah. So, start mixing this stuff because, it makes crazy stuff. You can add more IP adapters. You could mask the IP adapters. That's actually interesting. I don't know what that would do. Now I'm kind of curious. I'm about to nerd out here and try something. So I want to add masks to the IP adapters, which is easy to do because I'm using the advanced IP adapters. So let's plug these in, grab the IP adapter from the model loader, pass the model through, and now we have a expanded IP adapters. Now what I'm going to do now is pop over to a new workflow. And I want to create shape mask. All right. And I know my frame width and height is 576 by 320. So I want to make a square and I want to have a look at what it looks like. So let's preview the mask. I'm just trying to get the settings here. So let's have a look at it. So it's made a circle in the middle because I said a circle. Circle. What's half of 576? We go 576 divided by 2 is 288. Location Y is 320 divided by 2. So that should put the square in the center. Let's make it bigger. 256 by 256. Cool. So now we have this. So let's grab this shape mask. Control C. Go back to our other one. Pop it here. So this shape mask is going to make that square that we were talking about on our image. So the mask goes into the first one. The inverted mask goes into the second one. And we'll use a different image for the outside. Desktop inits. Let's do clouds. Hey, okay. We have clouds and stuff. So what it's going to do is it's going to take this square in the middle and put this image in there, and then this stuff on the outside is going to be the clouds. So it should be like a little square of stuff in the middle and then the clouds around the edges, but it should all be reacting to this. Maybe. Only one way to find out though. Can you mask the control nets? Control nets are masks, if that makes sense. Did I do this right? Yeah, I think so. I think I see it. So it should be clouds around the outside and then the other stuff in the middle. Yeah. So yeah. I mean, everything you can do in Comfy is pretty much extendable into every workflow, so go crazy. Yeah. I mean, this is a very extendable, expandable workflow. If you don't want to use IP adapters, you can just text prompt. We can bypass the IP adapters completely. We can say sunny beach, sun-kissed waves, flapping at sunset. And if I'm right, this should just make a beach. The IP adapter is just so that we don't have to prompt, Cool. Trippy. So yeah, the other thing I wanted to cover was if I don't have, let's say I just have regular footage, right? I don't have this cool stuff I made. I just have regular footage. Get rid of line art. Actually, no, screw that. Let's use the same clip. Boop. And then, so let's load a video of someone dancing. Okay. Every ControlNet, you can pre-process stuff into different ControlNet things that the different models can use. So in this case, we're using depth and line art. So we need to pre-process this footage into depth and line art footage. So let's do that. We got our image. We got our upscaler. We don't need this second upscaler because we're going to use this one to do both. This one is going to do a depth anything version 2 preprocessor. I'm going to add model loader. We're going to use VIT-I FP16. So the image goes through and then image goes into here. Same deal here. We're going to use a realistic line art preprocessor. We're going to pass this image into it and pass it in out there. So if we want to see what these preprocessors are doing, I'm going to move this out here with the settings. Okay. And then we're going to grab outputs from here, video combine. And another one of these out of here. We're going to turn off the save output, change them to MP4, and set them to 24 frames. So these are going to become preview windows for us so we can see what our control nets are doing. So we're feeding this clip into the preprocessors. The preprocessors are going to preprocess them into depth and line art, and then those depth and line arts are going to go through here. So hopefully we'll have a dude dancing on a sunny beach. So we've just generated depth and line art control net things from that simple one thing. So you don't need to make input footage. You can go get CC0 stuff and just do this with it video to video essentially. And you can see it's pretty powerful right out of the box. Hey. So yeah. ControlNet, IPAdapters, AnimateDiff, all of it, all works together. Everything makes a nice harmonious cake. Play with it. You can also use prompt travel. You don't have to use this. You can use, I don't have the nodes installed, but there's a scheduled prompt value thing where you can do prompt travel over time frame. You can use IPAdapter batches. Yeah, man. Consistent depth maps. I'm finding depth anything version 2 seems to be the most consistent depth maps. You can do other things like if I don't want all this crap in the background of my maps, we can do some mask compositing. So if we add BiRefNet, this only happens with people. Let's add a BiRefNet node. Let's add the BiRefNet model loader. So let's feed our video into this. Okay. So this is going to make a mask that we can use to separate the person from the background. So instead of feeding this thing, this image that we've made, I actually want to use the mask to just rip this stuff out and leave the backgrounds out. So let's do an image composite masked. Okay, we're going to need 2 of these. We're going to need a couple more nodes. We're going to need an image blank. We can use the same one for both. Width and height, I always recommend changing them to inputs and plugging them in because, you know, you don't have to think about it after that. Right. So we're going to make it black. That's red, green, blue, 0, 0, 0. So right now we're making the background for our masks, right? So we're going to add a repeat image batch because this only makes one image. So we need to repeat it to the length of these masks. How do we do that? Well, we change amount to an input and we plug the frame count into the amount. So it's going to make a mask, a black mask, the same amount of frames, and plug that into the destination of both of these. We're going to plug the mask into both of these. Okay. And our source is going to be these. So we want our depth anything to be the source, and we want our realistic line art to be the source. And we're going to plug these into here so we can see what they do. And we're also going to plug these into the input for the IPAdapter or ControlNet. So long story short, what this is going to now do is pull the background out and put the person on top of it and remove the background from these. And it's only going to show us the person. Maybe. Yep. Oh, I did a mistake. So one of my masks is off. Where are you coming from? You should be fine, BiRefNet. Why is my mask off center? Yeah, this is going to be a weird one. Okay, let me figure that out. The source is coming from here, which you're coming from there. Yeah, you're coming from here, going into... Wow, something is very weird. Something's getting resized somewhere it shouldn't be. That's super strange. I mean, that's not bad. We got into an hour before we had our first mistake. Oh, wait, why are you... Where else are you going? Composite mask aligner. Combine. Yeah. Well, it just goes to show you, you know, all roses all the time. Something's very broken, and I don't know why. So you're going in here. You're coming out of here into BiRefNet. You're coming out of BiRefNet masks. Yep, that's all good. Repeat image batch. Oh. Yeah, no, that's right. Yep, you're both in there. Just debugging here, trying to figure out why we're getting two different masks. So strange. It shouldn't be two different masks. Everything's correct. Well, one thing I could do then is maybe feed this into the preprocessor. Wait, where are you coming from? Yeah, upscale image. What? Oh, I guess I had to click the resize source. They seem to be linked up now. There we go. I think that's working. Hey. So now you can change the background. You don't have to have the same background. There he is. So yeah, that'll get rid of the, you know, whatever background was stuck in your footage. So you don't have to have like those pillars and stuff in the background. And then, you know, you can really extrapolate this and add a three-way mask for the IPAdapters to get your, the person, the ground, and the background. I have other videos on that, but like, yeah, this is all very extendable. Yeah. But yeah, we've got the mask of the person now, so you can just very easily feed that to an IPAdapter and then feed the foreground background to an IPAdapter off to the races. I've got many videos on that. All right. I mean, that pretty much covers everything I wanted to cover today. We got through it a lot faster than I thought we would. So yeah, go forth, make stuff, make depth maps, make line art, make normal maps, make all that stuff. You can make it in Blender. You can make it in other footage. You can pre-process footage you've already got into that footage. You can mask it out. You can mask stuff onto other stuff. You can VAE in Paint on top of new layers. Comfy is just a giant playground for you to break stuff. So yeah, get out there and have fun. Thank you so much for hanging out, everybody. And yeah, Pers loves you. And hit up the Patreon, hit up the Discord. And yeah, I'll be back on Thursday with my guest, Enigmatic E. So check out Enigmatic E on Twitter, Instagram, and YouTube. We will be hanging out and making some cool stuff together on Thursday. I believe that's at 3:30 p.m., but I will send more updates very soon once I check my calendar. Thank you, everybody. Have a great night, and we'll see you all very, very soon. Bye-bye.